Hi, welcome to another video from Equaser.com. In this video, I'm going to show you how you can do the conversion between binary, decimal, hexadecimal, and octal, and other simple basic base-in calculation using the Casio FX-991EX, which is in front of me here. One thing to clear at the beginning, that this cannot do the decimal value of, let's say, 1.4 and 1.3 to binary. This calculator is not capable of doing that. It can just do a full decimal value, which means 3, 5, 22 or something. Anything that has point, this calculator is not capable of doing that, so you have to do it with pen or other methods. So let's get started. To go into base mode or binary, decimal, hexadecimal, press menu on the screen. This has 2, 8, 10, and 16. So this is base in when I bring it with my left and right arrow. Or you can directly press 3 to go for that option. I'm pressing equal sign, so pressing 3 or equal is the same. Now we are in this type of calculation. Now we are in decimal. We have 4 main buttons here: decimal with a blue label here, this x squared and so forth. So decimal, hexadecimal, binary, and octal. So there, when you press it, it will not press x squared. It will just function for this purpose. So when you enter the value, let's say this, we want to convert 35 decimal to binary, the screen must be in decimal. So otherwise, if you enter other value, this will not accept it. So I'm in let's say if I go to binary, and if I want to enter 8, you see I'm getting error, so press all clear. Now I'm going back to decimal, so you must be in decimal. So 35, and then you have to press equal sign in order the value to be entered into the system before converting it. Now I'm pressing bin, which is binary. Now this is the value. You will see a lot of digits, but depending on your calculation, either you have 6, for this one is the minimum, 6 bits from the right, just count it, or 8 bits. So if you are using 8 bits, the first 4 bits and then the other 4 bits, so this is total 1 byte. So the value of 35 to binary is 00100011. But if you're considering the 6-bit, just start from 1. The 0 on the left has no meaning except it tells you the number of bits available in the system or in your calculation. So let's go for the other value, for this value to decimal. Now we are in binary, press all clear, AC. So 1001101. I enter the value and then equal. Now this is in binary. To convert it to decimal, just press this button. So now this is 77, the value converted. Now let's do some calculation for 236 octal to decimal. To go to octal, this is a button, the last one. So we press it, octal, all clear, clear the screen. And then 236 to decimal. So 236 equal. Remember, for octal you cannot have 8 or other value. If you have 8, if you press equal, you see you are getting error. So 236 equal sign. So this is octal converted to decimal, press decimal. This is 158 to decimal. Now to convert 87 decimal to octal, I'm pressing octal, so you know, just press decimal. You must be in decimal, enter 87 equal, and then octal. That is 127. Now let me do some hexadecimal to decimal. Hexadecimal has A, B, C, D, E up to F. And these are the value A, B, C, D, E, F. The first, this row, all of those with red labels are working for hexadecimal values and for other purpose. So let's go to hex mode, press hex button, all clear. Now A0 to F. For A, I'm pressing this one because this is labeled as ABC, that's red A. 0 2, and then for F the last one, A0 to F equal sign. To convert it to decimal, press decimal. Now remember, if you want to convert it to any other value, just press that button after the value is here, not here. You must press equal sign, so it should be here. Decimal, that's 41,007. So now I'm already in decimal. Let's say you're in binary, just go to decimal. I'm converting 102 to hex. 102, press equal sign, the value is here. Now press hex. So this is 66. Now those are the conversions, so you can convert between any of those with just entering the value and pressing the button. But let's say you want to do some addition, simple calculation. Let's say you want to do hex. This is B to C hex and 134 hex. So you must be in hex, which I am already. So B, 2, and C plus 134. The value is 06C. 0C60. Same way for binary, just go to binary and then all clear. 1011 plus 0101. Now this is the answer, 00001. So if you're considering 8 bits, just put this 0 as well. Now for calculating OR and NOR and other values, let me just put this. For AND means this is the input A and input B, and this Z is the output. It can be represented as a switch AB. So the current passes through, in order the current or signal passes through A, and B must be connected to pass. So this both must be 1 in order to have at the output 1. You can see 1 and 1 is 1. All other combination of 0 and 1 and 1 and 0 results in 0. So that's called AND. Let's do a calculation of let's say 0 1 1 0. So we want to AND it, and to do the AND we press option, and you see some other values, and the scroll shows that we have other stuff, decimal, hex, binary, so other options. So and number 3, I'm pressing AND, so you see 0 1 1 0 and 1 0 0 1. So the result is all 0, because at no point this is 0, this is 1, the first one, the second one 0, and then 1. So none of these are 1 to get the 1. If you want to change the value, just for AND means this is the input A and input B, and this Z is the output. It can be represented as a switch AB. So the current passes through, in order the current or signal passes through A, and B must be connected to pass. So this both must be 1 in order to have at the output 1. You can see 1 and 1 is 1. All other combination of 0 and 1 and 1 and 0 results in 0. So that's called AND. Let's do a calculation of let's say 0 1 1 0. So we want to AND it, and to do the AND we press option, and you see some other values, and the scroll shows that we have other stuff, decimal, hex, binary, so other options. So and number 3, I'm pressing AND, so you see 0 1 1 0 and 1 0 0 1. So the result is all 0, because at no point this is 0, this is 1, the first one, the second one 0, and then 1. So none of these are 1 to get the 1. If you want to change the value, just press left arrow key, come here and make it 0, and then equal. Again 0 and 0 is 0. So the second bit should be 1 in order to get 1. So 1 0. Now we are getting 1. So that was for the OR. Any of these, when we have one value, it will pass. So this is as the same as the two wires. So A is connected, the current passes, or B is connected. Both of them are connected, also we have signal passing. So the same way, so 1 0 0 1, and then press option and then number 4, which is OR. So that's the answer. Now let's look at the exclusive OR. Exclusive OR mean exclusively one of them should be 1 to get 1 at the output. So A and B are input, Q is the output. So when it is 0, so it's 0. Both of them are 1. Unlike the OR, this is 0 because exclusively we want one of them to be 1. So this is 1, we got 1, and then 0 and 1, 1. So let's do XOR 1 0 1 option, and then XOR number 5. Okay, so exclusively OR, only 0 and 1, one of them are 1, so we can get it. The last digit, which is both 1, is 0, the middle one is 0 0, so that's XOR. XNOR, just the opposite of XOR. So when there is two of them exclusively 1, it's 0, and then it's quite the opposite of that. So let me go for 1 1 0 option XNOR 0 1 1. So this is the XNOR. Why we see all these ones? Because we assume all other value previously were all zeros, so it converts it to 1, all of them. Thank you very much. If you like this video, please thumb up, and also if you subscribe to my channel, please do so now.